Sixth, sixth case. Let me raise first of all. Case number 6. Case number 6. First of all, let's draw a figure. Let's draw a figure. This is beta angle and this is alpha angle. There is a pulley. This is object. Another object is over here. There is another object. T tension. Acceleration is here is acceleration. This acceleration is upward. This acceleration is upward. Means object is going upward. Over here object is going upward and over here another object is going downward. Due to acceleration. Now everything is written over here. Case number 6 is case number 6. We are writing case number 6. There are two objects. This one, this is secant. This is pulley, and there is one angle. There is another angle. One angle is alpha. Secant angle is beta. Okay. If a question is coming like that, then how to solve? How to solve like that question? Okay. First of all, make a FBD for different bodies. If there are two bodies, then make a FBD for them. Condition is if M1 Z sin alpha is greater than M2 Z sin beta. Look over here. We will get mz, or you can say this is a m1 and this is a m2. Clear? So m1z. Let's break components. This will be our according to this theta. This will be our m1 z sin theta according to this angle. Okay. And downward will be perpendicular will be next component will be m1 z cos theta. And we got two components of m1 z. Same with this secant m2. Our mz will be like this, m2z. So according to this theta, this will be our according to this theta. Components will be, that is how components will be there. So according to this theta, this will be our m2z and sin theta. Okay, and this will be m2z cos theta. But remember, we have over here alpha and over here alpha, and over here beta, and over here beta. Clear? Beta. Now condition is if m1 z sin alpha is more than m2 z sin beta, sin beta, sin beta. Okay, if this is more, suppose the m2 will go upward. In that situation, remember, in that situation, for mass m, let's make FBD for mass m1. What are you observing? m1 is over here. This m1 z sin theta is equal to t. But there is a solution. That's why mz m1 z sin theta minus t will be m1 into a. This equation we will get for mass m1. Okay, for mass m1. So m1 z sin alpha minus t will be equal to m1a. Okay, this is our first equation. Remember, for second body, we know acceleration is upward. That's why t will come firstly, t minus m2z sin beta. Okay, m2z sin beta will be equal to m2a. This is our second equation, and add these two equations together, then see what is coming. Add equation. Okay, now t will cut to each other. Reason is minus t plus t. That's it. So here m1z sin alpha, this minus m2z sin beta will be equal to, here is a common m1 plus m2. Okay, this will go downward. And see, are you getting a common variable in this equation? Answer is yes. Z is a common. So m1 sin alpha minus m2 sin beta upon m1 plus m2 means total mass will be equal to acceleration. To calculate acceleration, we will use this formula, which is equal to z into m1. Z is a constant for both, so equation will be for a. A will be equal to z into m1 sin alpha, minus m2 sin beta upon total mass, Okay. And you know that A is equal to F upon N. Same thing we are getting. So over here we have what? Force. So final force. This final force minus initial force. This is going downward. So downward force minus upward force upon total mass will be our acceleration. Remember. So downward force minus upward force, m2 sin beta. This is going upward, this is going downward. So C is a constant, m1 sin alpha minus m2 sin beta upon total mass. Okay, it is not different, just there are components, and here we have f upon n, and we put the value of f over here and value of m. That's it, we did. This was sixth condition. Yes. Now what would be t? Value of t. Just put the value of a in first equation. So t over here. This t will become m1 a minus A is how much? Z m1 sine alpha minus m2 sine beta upon m1 plus m2. Clear? Now this minus m1 z sine alpha. Clear? Sine alpha. This will be our t. But something is common. Finally, you will get m1 into m2 sine alpha plus sine beta upon total mass into z. This z will be over here. Look at denominator. M1 is a common, so that's why M1 is over here. M2, then M1 Z M1 sine alpha. This is common. At the end, you will get T is equal to M1 into M2 sine alpha plus sine beta into Z upon total mass. Try to understand. Can you say that M1 alpha, this is common? Okay. Let me erase and see seventh. And see seventh. Case number 7. Figure will be different from the previous. There is a roof. Okay, there is a roof. One pulley system. Then the first string with one mass M1. Acceleration is upward. And second pulley system. Second object. M2. Acceleration is downward. Then again object M3. So tension over here we have 2. Over here T1 and over here will be T1. Okay. If a question is something like that, there would be a pulley and a lot of objects like that will be there. Now for M1 we can write this will be M1Z, for this M2Z, for this M3Z. Am I correct? Okay. You can say T1 is equal to no, not at all. For M1, you would say if acceleration is upward, then T minus T minus m1z will be equal to m1 into a. This is first equation. Okay, this is first equation. For m2, downward is how much? T2 plus, or you can say T2 minus T1 will be equal to, so for T2, this T2 and M2 plus Z, M2Z, okay, M2Z minus, direction is down. So T2, we are talking about this. So T2 plus M2Z, over here, this will give us M2Z. Okay, this force plus this force will be equal to reason is this is T and this is also T, that's why, and both are upward, so the direction will be same. T2 plus M2Z minus T1 will be equal to M2A. Try to understand this complete force downward. Okay, downward. This is a T2. T2 is for this object, and M2Z is for M2 object. So T2 plus M2Z minus T1 will be equal to, this is our net force, and M2 into A. Now it's a time of M3, for M3, downward force. So M3Z minus T2 will be equal to M3A. Okay, this was the second equation. Now we have third equation. Add them together, then see what equation you are getting. These are APBD of different bodies. Solving equation by adding or subtracting, it's your choice. Solving equation, then you will get what you will get is equal to, okay, let's see, T2 T1 will cut to each other, isn't it? Z is a constant. Can you write M1 is a minus, so over here J is a constant, M2 is a positive, M3 is a positive, M1 is a negative. Clear? This LHS is clear. Now in the RHS, what is a common? You would say A. M1 plus M2 plus M3. Okay, M3. This will go into denominator. Z M2 plus M3 minus M1 upon total mass is equal to acceleration. This equation we will use to calculate acceleration if a figure is like this. Okay, so net force upon total mass is equal to K. M2Z plus M3Z M2Z plus M3Z. These are total force, okay? Total force, which is a downward. Total force minus upward force. Total force minus upward force. So M1Z, you can see M1Z, okay? Upon total mass. Total mass is how much? This 1, 2, 3. What are you understanding? Downward force, complete downward force minus complete upward force upon total mass. This will be your acceleration when it comes to tension. Okay, this is done. M2Z. J is a constant for each body. Now we have a question. We have question. Now we have a question. Okay, no problem. Found out acceleration. Find out the acceleration. Okay, acceleration and the tension of a block and tension of a block object. First figure in front of us is like this. Okay, pulley is over here. Mass is 2 kg. 2 kg mass. T upward. Okay, no problem. Over here. Object is 4 kg. Acceleration is forward. Of course, if this is 4 kg, there would be no acceleration. Reason is this object is mass of the first object is mass. That's why there will be no acceleration. Now you can find mg for this t would be how much? You would say mg 2 multiple 10, 20 Newton. Okay, 20 Newton. Question is asking acceleration. Let's assume question is asking acceleration. For acceleration we have complete downward force. Okay, downward force is how much? 20 Newton. There is no. So over here answer would be A is equal to 2z upon 4 plus 2. Complete, look at over here. Complete mass is how much? 4 plus 2. Complete force is how much? Answer would be, this was mg. Downward force is 2z. Okay, 2z or 20, same. So total force is in this side backward you can see there is no force. Downward is how much? 20 Newton. So 20 Newton upon 6 will be, or you can say 2z upon 6. 2 3s are 6. Answer is z upon 3. Just put value of z. You will get acceleration. Now, tension. Okay, tension force. This was A. B is a tension force. To calculate this tension, we have the equation which is known as T is equal to ma. T is equal to ma. T is how much? Mass of the block is I'm talking about this. So mass of the block is 2 multiple acceleration is z upon 3. Acceleration is z upon 3. So that's why 2z upon 3 will be our tension for this 2z upon 3. For this tension will be 4z upon 3. Clear? Just T is equal to 4a. T is equal to 4a. For the first block. For the second block, T is equal to 2a. 2a. Second question. Second question. This triangle 4 kg. Two kg. A is over here. Angle is at 30 degree. Now see over here. We know mg will be for the 4 kg block. Mg will be how much? 4 multiple 10, 40 Newton, or 4z. For this, mg is over here. Okay, mg is over here. You know. So one component will be mg costed, not costed but sin theta. Remember, sin theta. Acceleration, there is no acceleration. mg sin 30. There is no acceleration. If acceleration is zero, remember, question is asking what would be, you know, acceleration is not given by the question. So look at over here. This is 2 kg, this is a 4 kg. Which one block will go downward? You would say this 4 kg. So acceleration is a downward. This 40 minus this much. MC30 will be how much here? M is 2, 20 multiple, so 10 Newton. So 40 minus 10 upon, remember, 40 minus 10 upon 2 plus 4, 6, 30 upon 6, 15 to 0, 3 to 0, 3 5 0, 5 meter per second raised to power 2. This is our acceleration. What did we do? Just we saw that this is our downward force and backward force. Backward force is this much. So downward minus backward. 40 minus 10 upon total mass. So G is tension. For tension, 4G, this 4G minus T will be equal to 4A. 4G minus T will be equal to 4A. From here you will get tension. So T will be as it 4A minus 4Z. 4 is common. A minus Z. A minus Z. Or you can say T will be equal to, this is correct. This is correct. Now see over here. Z upon 2. Value of A is Z upon 2. Just put value of A. G minus A. Then over here, G minus G upon 2, 4, 2Z minus Z. Then you will get Z upon 2 to the 4. T will be 2Z. Means Z is a 10. So our tension will be 20 Newton. That is how you will find tension and acceleration. Here we wrote 40, this acceleration was downward. So 4G minus T equal to 4A. Then we saw that T was equal to 4A minus 4G. Value of A was given. And that is how we brought T as a 20 Newton. Third question. Figure is triangle again, triangle. This is 30 degree and this is also 30 degree. There is one pulley, one object whose mass is 2 kg. Acceleration is upward. Another object whose mass is 8 kg and acceleration is downward. That's it. Tension. Okay, that's it. Now, according to this data, we can found what? MC will be like this. MC. So this one component will be mg cos 30. No, cos 30, sin 30. Okay. mg sin 30. M is 8. 8 multiple 10. 80 and by 80 by 2, 40. So over here we have 40 Newton. How much? 40 Newton. For this, M is 2, 20 upon 2. 20 upon 2 will be our 10 Newton. This much Newton is stopping the 2 kg block to go upward, and 20 Newton, this much Newton is acting on the second block so that the block can come downward. Okay. Now, question was asking, what is it? So downward force is how much? 14 Newton. 14 Newton minus upward force, which is a 10 Newton, upon total mass 2 kg plus L. This is 10. 20 upon 10 will be 2 meter per second raised to power. This is our solution. A is 2 meter per second raised to power 2. Okay. This is one answer. Second is a tension. Look at over here. Direction is a downward. So 40 minus T will be equal to 8A. A is a 2. So minus T will be equal to 16 minus 40. 60 plus 40. 56 Newton. This much 56 Newton. Okay, 56 Newton. Hg upon 8z upon 5. So 10. 85. T is 60 Newton. Newton. Eight z sin 30. Okay, 8z sin 30 minus t is equal to 8a. Okay. 8 multiple 10 multiple 1 by 2 minus t will be equal to 8 multiple 2. 8a upon 2 minus t is equal to 16. 40 minus t is equal to 16. Yeah, same. Minus t is equal to 16 minus 40. 40 minus, then this will become positive, minus 16 plus 40 will be our 24 Newton. 24 Newton. Four z minus t is equal to 8 multiple 3z upon 10. 24z upon 10, 5 2s are 12 2s. This is our answer. Minus 16 plus 40. Now next question. Next question. next question is fourth. Pulley is over here. This is our question. Again, what would be A and T? Here, A is going to be how much? 3. 3, okay? 3Z. This will be our 3Z, hence 30 Newton. 30 Newton. 30 Newton, or you can say 3Z. Okay? Okay. Acceleration is like this. There is no force. There is no force. There is no force. Backward, you can say backward, there is no force. So 3Z will be equal to 3Z will be our net force. Object, nobody is stopping the backward side. This block is pushing all these two objects downward, or you can say forward. So total mass is almost 4 plus 2, 6, 9. So our acceleration would be Z upon 3. This is our acceleration. Okay. Now C is a tension. Tension. But what? It is talking T2. Can we write it like that? 3Z minus T2 is equal to 3A. Yeah, we can write it. 3Z minus T2 is equal to 3A. 3A. Value of A is given over here. So 3Z minus T2 will be 3Z upon 3. This will cut to each other. Minus T2 is equal to Z minus 3Z. Okay. So T2 will be minus Z plus 3Z, which is equal to 2Z. Which is equal to 2Z. 20 Newton. 20 Newton. 20 Newton. Over here is a 20 Newton and this is a 30 Newton. According to acceleration. This is our correct answer. Next says this was a T2. Okay. What about T1? T1. What about T1? Remember. There is no force, isn't it? So over here we can consider T1 as a normal reaction. So T1 is coming from this object. So T1 will be equal to 2A. Okay, 2A, or you can say 4A. 4A, which is equal to 4Z upon 3. 4Z upon 3. This is our T1. Okay, tension over here will be something else and over here will be something else. That is how you will calculate. That is how you will calculate like that question. Now next question. Next question is, three kg T1 acceleration is a downward, and there are two objects. One is a 2 kg, second is a 4 kg. 4 kg acceleration is forward. T1 try to understand. Over here mc will become 3z. Backward there is no direction. Backward there is no direction. Let's solve. A will be, so 3z is the total force upon total mass. So total mass will be, there are three objects, 4 2 6 9. Again z upon 3 is our acceleration, same acceleration. Okay, but when it comes to tension, you know that tension can be written as 3z minus t is equal to 3a. 3z minus t is equal to 3a. Value of a is z upon 3. 3z minus t is equal to 3 multiple z upon 3. Okay. Minus t is equal to z minus 3z. Minus z plus 3z will be our 2z. This is our tension over here, 2z. Okay, but C is normal reaction. Normal reaction would be 2a. Over here normal reaction would be how much? 2a. Normal reaction of a 2 kg body on 4 kg body would be 2a. 2 multiple z upon 3, which is a 2z upon 3. 2z. This much force this object is applying on 4 kg block. Okay. Now next question. A chain of mass M is attached at 2 points A and B of two fixed walls as shown in the figure. Find the tension in the chain near the at the point A and at the midpoint C. This is our question. There is a chain. Midpoint is over here. This is midpoint. A chain of mass m. Mass of a chain is m. Is attached at 2 points. This one point, the second point, which is B. This chain is attached with 2 points of a 2 fixed wall. That's 2 fixed wall. As shown in the figure will be given by the question. Okay. Find the tension. Find the tension in the chain. In the chain, what would be tension? Near the walls, over here and over here. Near the walls at point A and at point A and at the point at the midpoint C. First, only tension, not isolation. So at point A, tension would be how much? First, try to understand. This is our one wall and second wall. Okay. This is how chain is attached. By making theta angle. Okay. Now midpoint is, this is our midpoint. Okay. This is our midpoint. Okay. So from here would be our vertically opposite angles. Vertically opposite angles. According to this theta, try to, here alternative angles will come into picture. If this is theta, so according to alternative angles, this will be also theta. According to this theta, this will be also theta. Okay. Till here we are crystal clear. This is T sin theta and T sin theta. According to this theta, at this point what would be this T according to this theta? So you would say that tension is going upward. Tension is going upward. This will be T cos theta. Same over here. T cos theta. There are two components of this tension T. This tension, we are talking about this tension. According to this theta, this will be our T cos theta, T sin theta. Okay, same over here. So if this is theta, so this will be also theta. If this is theta, so this will be also theta. So according to this theta, T cos theta will exist over here, and T sin theta will exist for this. Okay. We brought this theta from here, and we brought this theta from here. Okay. you know this is nothing but it is midpoint. So midpoint will be 2t sin theta, 2t sin theta, and this side will be our t cos theta, t cos theta, again t cos theta. So there are two, and remember, vertically there are two t sin theta. That's why we wrote 2t sin theta, because there are two t sin theta. One for this t cos theta, one another for t cos theta. Now you can easily write what 2t sin theta is equal to mg, downward would be mg, and 4t, we know 4t this will be equal to half mg cosec theta, half mg, where is it? This theta, t will be equal to half mg cosec theta. Okay, now second question is tension along horizontal direction, like this, t cos theta. It is talking about t cos theta. In same everywhere, no external force there. If there is no external force acting on it in horizontal direction, then at the point C, what would be our tension at point C? What would be tension? This is what question is asking. Okay, horizontally. In that case, remember your t dash will be equal to t cos theta. It is talking about this horizontally, t cos theta, which is equal to mg cos theta upon 2 sin theta. mg cos theta upon, this is mg cos theta upon 2 sin theta. We will see it later. Now next, is first. This is a small part x, and midpoint is P. F is in this direction. Question is asking, in this case, tension is the same through the length in massive string. Tension will be same throughout this rod. Tension will be same at every point. So we have to find the tension. Okay. So remember, M is 4. This is a small m, and M is a 4 big. complete m and minus a small m will be our empty area. So big M minus M will be equal to this, will give us a tension. Clear? Tension. Now you know that F is equal to M. Mass is what? M minus M. A will be your F upon M. So your tension would be in this direction, isn't it? From this a small part. F minus T will be equal to M multiple A. F minus T will be equal to net force. And we know that a small m is equal to big M upon L into X. This thing we know. Just substitute the value of this small. F minus T will be equal to M upon L into X into F upon M. Value of A and value of M. From this you will get tension 1 minus X upon L. That's thing you will get. T is equal to F into 1 minus X upon L. That is how you will get your tension. F was MA and A was F upon A. This is value of A, and we know that this is a forward force minus backward force is equal to MA. So value of M is what? Big M upon L into X, and value of A is F upon M. After simplifying this, we will get T is equal to F into 1 minus X upon L. This will be your answer.